For this question, we have a line drawn here, and we're trying to find the slope of that line. Now, we're going to express the slope as a fraction here, where the top part's going to be called the rise, which is how much the line is changing in the vertical direction, up or down. And the bottom part is the run, how much is the slope changing in the horizontal direction, left to right. And so the easiest way to do this with something that's drawn is to find some points that are nice perfect coordinates. Like right here, we have the coordinate -1 and 4. So those are nice whole numbers. So that's a good point to take note of, because it's hard to know what the exact coordinates are for any of these points unless they go through a nice intersection of whole numbers here. And here we have another one that's -4, -1. All right. And so if we start at one of these points, we're just going to count how much it changes in the direction to get to the other one. So it changes 1, 2, 3, 4, 5, and that's going upward, which is a positive direction. So I'm going to leave it as a +5. And after I've gone upward 5, I need to go 1, 2, 3 to the right. And again, the right is like a forward positive direction. So our slope here is 5/3 for this line. Now, if you would have started with the other point, you would have got the same answer. You would have started here and you would have said, okay, to get to this point, I need to go 1, 2, 3, 4, 5 down. So down would be negative. And then after I've gone 5 down, it's over 1, 2, 3, and I'm going left. So left is negative. So two negatives cancel out. So you again get that same exact slope of being 5/3. For this next question, we're going to graph an equation using the intercepts. And I have a wrong answer drawn here, but we're going to show how to get from this equation to the correct answer. So one of the intercepts is on the y-axis, and the other intercept is where the graph crosses the x-axis. And so to find where it crosses the y-axis, that means x is 0, because we haven't gone anywhere from the origin. Our x value is 0. We don't know what the y value is. So we want to plug a 0 in there for x, and we're going to solve for that unknown y value. So if you plug a 0 in here for x, 3 times 0 is 0. So you're just left with 5y = 15. Divide both sides by 5, and y has to be 3. So that unknown y value when x is 0 is 3. And now we're going to do the same thing for the X intercept, where we cross the x-axis here. The y value will be 0, because whenever you're on the x-axis, y is 0. So we know what y is, we don't know what x is, but we're going to plug a 0 in here for y. And 5 times 0 is 0, so you're just left with 3x = 15. Divide both sides by the 3, and you get that x has to be 5. So that is the point where the graph intercepts the x-axis. So a line that goes through both of those points would be our correct answer. It looks something like that. Do another similar one here. Let's start by finding the y-intercept. That means x is 0. We're going to see where it crosses the y-axis. So we plug a 0 in here for x, and we would have y = 4 times 0, which is 0. So our y-intercept is 0, 0. And then we're going to plug a 0 in for y. Now we're going to find the x-intercept. So then you get 4 times x, a 0 for y. You get 4 times x = 0. Divide both sides by 4, x = 0. So we're just getting that 1.00. That's where the graph crosses both the x and the y axis. It crosses them both at the same time at the origin. So we actually need one more point in order to graph this line. So we can just pick anything we want and plug it in for one of the variables and solve for the other. And I'll pick 1. It's a nice small number. And I'm going to plug that in for x, and we're going to solve for what y is going to be. So if I plug a 1 in here for x, I get y = 4 times 1, so y = 4. So when x is 1, I go up to y = 4. And I always like to do at least 3 points when I'm graphing. And I'm just going to do that here just out of principle, because If you get 3 points that are all in the same exact straight line, then you can be very confident you did not make a mistake. So plug a 2 in here for x, you get y equals 4 times 2, which is 8. So when x is 2, y is at 8. And since all 3 of these points are on the exact same straight line, I can be confident that I have the correct line, and there it is. In this question, doing the same thing, I have an incorrect answer drawn, but we're going to get the right one here. First, let's find the y-intercept. That means x is 0. If I plug a 0 in there, it's 3 times 0, so y would just equal -3. 0 minus 3 is -3. So I get 0 for x, and our y-intercept is -3. And then I'm going to find the x-intercept now by plugging a 0 in for y. So this would give me here 0 equals 3x minus 3. I need to do a little bit of algebra. Add 3 to both sides. 3 equals 3x. And now divide both sides by 3 and you get x equals 1. So when x is 1, y is 0, that is the other intercept that I can now draw the line that goes through those 2 points. Now, just out of principle, let's go ahead and solve for one more point and make sure that all 3 of those are on a straight line. If I plug a 2 in for x, I would get y equals 2 times 3 is 6 minus 3. So y equals 6 minus 3, which is 3. So the point 2, 3 would be a third point. And now I can verify they're all on a straight line. I have the correct line, and it looks like that.